Welcome to Microsoft Build 2017. Hi, my name is Chris Segura, and I'm a PM in the Azure Cat organization. If you're not familiar with what Azure Cat does here at Microsoft, we're a team that helps internal or external partners or customers put together end-to-end solutions based on Azure IoT services or the PaaS services, etc. What I do in this team is focus on IoT scenarios, specifically in the hybrid space. So scenarios where you might have some mixture of both on-prem private solutions or public cloud solutions. So what I want to talk to you today about is a project I've been working on here at Microsoft for the better part of a few months now. A project that is aimed at connecting our buildings here on the Redmond campus to the cloud. Now, unfortunately, I don't have enough time today to cover the end-to-end solution in any level of depth. But what I will do is give you sort of an idea of what it looks like, how it works, and then we'll spend some time focusing on the Azure Edge solution, the solution we're using to take data from the building and put it into the cloud. So again, we'll spend some time overall. We'll look at the Edge solution. We'll reflect that into how we use Edge, the IoT Edge solution, to build a gateway that takes this information, put it in the cloud, and then we'll finish off with a quick demo. All right, let's go ahead and get started. Before I go too far, let's talk about what smart building actually is and what smart buildings are. So most people watching this video presentation might have a concept of a smart building being, hey, somebody's added some sensors to detect occupancy, right, a PIR sensor. Some people might think we're adding sensors to detect air quality, noise pollution, these kind of things. Those are almost definitely smart building scenarios. They're not the scenario I'm talking about today. The scenario I'm talking about today is a scenario that already exists, although you may not know it. It's a scenario that exists in most commercial buildings, at least in the United States and around the world. It's a scenario that revolves around the building equipment that's used in the HVAC system. So equipment like VAVs, variable air volume units, equipment like building chillers, even power meters are all already connected, although you don't know it. They've been connected for the better part of 20 years now. So the way they're connected today is using this protocol called BACnet, Building Automation and Control Network. Now, this protocol wasn't really designed to connect to the cloud. It was more meant to automate a building, right? It's in the title, Building Automation and Control. But the data that you can get from this equipment today is super useful if you look at it on a campus-wide, a building-wide, or even corporate-wide level, right? So the challenge is I have all this data, but it's kind of stranded in this island. How do I move it off of this island and put it in the cloud so I can look at building information from here in Redmond, or building information in California, or building information even in Taiwan? So this is the challenge that we're faced with, and this is where I'll spend some time talking today about how we solve that challenge. So again, we'll spend most of our time on the gateway side, sort of the on-ramp of this data into the cloud. Real briefly though, the cloud solution looks like most other IoT solutions you're probably familiar with, right? As soon as it goes into the cloud, we're talking to things like IoT Hub, which is managing the data, managing our devices as well. Behind IoT Hub, you have components like ASA, Azure Stream Analytics, right? Taking that data, looking at it real time, and doing something with it. And that something sort of depends on what the actual data is and what the device that we're monitoring is. But then you imagine we put that into some sort of storage. From that storage account, you can also do some analysis on it, right? You have a presentation layer above that, a presentation layer based on Power BI. You can even imagine that at some point we would add in things like Dynamics, right? So again, unfortunately, don't have enough time to talk enough about the cloud side, but keep this picture in your head that the data we're putting into IoT Hub has a whole ton of great information underneath it. We're using the IoT suite of components to monitor that information and understand that information over time. What I'll focus on today is just the gateway solution. All right, so before we go into a demo, before we go into the actual solution, let's talk about IoT Edge and how it works, right? So let's take this scenario where I have this legacy protocol, a protocol that has no concept of the cloud. How do I connect it to the cloud? So ignoring technology for a second, you can envision I have two sort of main components that I have to solve for, right? I have a component that looks like, that needs to talk native to this interface, right? That somehow understands the native language. You can also sort of fold into that I will put at the output of that something that is more modern, something that is more cloud ready. In this case, I'll just give you the answer. It's a JSON sort of container, if you think about it that way, a JSON payload. Now that's not quite cloud ready yet, right? JSON isn't a communication protocol in that sense. It can't talk to the cloud natively. So what you need to do is take that payload and wrap it into something that is cloud ready, something like AMQP or MQTT. And that's what the other side of this equation looks like, right? You have a module here that says, okay, I can talk native to this network. I can put it into something a little bit more consumable, but finally the endpoint has to be, okay, let's wrap this in AMQP, MQTT, HTTPS, and we'll send it to the cloud. So at a minimum, I need these two solutions. But what else might you want to do in this scenario, right? You might want to do some local filtering, some local aggregation, right? You might even want to do device management. All of these are valid scenarios for this use case, but I will argue right now that these are optional, right? They're sort of dependent on the environment you're in. Maybe perhaps your building is small enough, and maybe it's a building of one, that you don't really need to do device management. You can just send somebody over to manage the device locally. Maybe you don't care about aggregation and filtering, right? So all of these optional modules are things you can add in over time. And the reason I highlight these concepts is because this is what Azure IoT Edge helps you solve for, right? Edge itself provides sort of the underlying infrastructure, an infrastructure that you can use to put up communication channels between these modules and help one module talk to another, help another module share data, even help modules understand, do I need to take any action on the data that's being passed before me? Now, if you're unfamiliar with the way you architect modules using Azure IoT Edge, the way you do it today is you define the infrastructure of what these modules look like, how they're connected via JSON file. Now let's take some quick look at what this JSON file looks like. This is a generic one, but it'll give you an idea of what's going on. So high level, right, how I add or subtract modules from this solution is I simply add the DLL that implements that module function. Right? You might imagine I have a DLL that just simply has the protocol translation logic in it. I might have a DLL that does device management for me, right? So the way you add it in is sort of highlighted here on the screen. And it's simply you just add or subtract these DLLs, restart the gateway, and these DLLs will take action. These DLLs, though, might need some information to do their job. And the way you give them that information is by passing in arguments. You'll see highlighted here at the top, some of the arguments I'm passing in are things like, well, what is the IoT hub name? Who am I actually sending data to, right? So you can envision it's a URL that I'm passing in there. I've mentioned a few times, we need to use a cloud transport protocol, something like AMQP. Here I define it, right? I just simply add in, I'm using AMQP, please use that protocol transport. I could simply change this to MQTT and the transport mechanism will change. I don't have to pass in arguments, right? You see at the very bottom here, the two arguments for the other two modules are null. Those modules do things on their own. They don't need any arguments from the outside. They just start. So again, super high level view. In the next few slides, you'll see some details of what arguments I'm passing in, how we're using those, and then a little bit of the code behind it. All right, so final concept here, concept of links. This is how you set up communication from module to module. You can think of it as either setting up a system of multicast links, right? All modules can talk to me, or unicast links. I only listen to and I only talk to this particular module over here, right? It's sort of up to you. You'll see again in code in just a little bit how we filter through these messages and sort of understand, okay, what action do I take on this message? All right, so basic concepts out of the way. Let's fold that into what the solution looks like for our backnet and for connecting our smart buildings to the network. Let's see what it looks like. On the left-hand side here, you see a sort of stylized generic backnet network. It's generic, but it's largely true of what the network here looks like at Microsoft. Let me highlight a few things. On the very far left there, you see sensors. Now, I've mentioned these sensors exist in buildings, right? These are sensors that are up in between floors. These are sensors that are up on the roof. They may be on the walls outside on the power meter. These sensors have a ton of data they take a ton of data from their various components. They take things like temperature. What's the temperature of the room? They take things like, what is the temperature of the air being passed through the building as I try to cool a room or heat it up? How much power am I using? What's the status of my chillers? What is the position of an actuator? So there are a very large number of sensors in most commercial buildings. Just as a way of reference, our building 19, just across the street here, has over 1,600 sensors in it, right? And that's only across 2 floors. You might imagine a multi-story building has several thousand sensors in it. Those sensors, though, are only part of the story. Those sensors talk to a controller. Now, the controller has all of the logic for BACnet, like what position do I turn that actuator to make the airflow at a certain rate? What does it mean when this particular sensor has a value of 82 degrees Fahrenheit, 82 watts? What does that mean? The controller contains all that logic. And then at the very right-hand side of this, you see a thing called a BBMD. Think of that right now as just simply a router. It's a BACnet-specific router, but it is just a router. It helps send messages from one side of the network to the other. Now, the way our solution works is we have a gateway, right? It runs on a piece of hardware. And if I didn't highlight it in the last slide, the SDK that we're using, the Edge solution, is written in ANSI C. So that means it's very portable between platforms, right? It worked very well in Linux, it works on Windows, it works on several RTOS releases as well. Our solution today runs here at Microsoft on a set of servers because that's the compute that we had open and free for this project. Other places they're running on very simple devices, very simple industrial PCs that are running some forms of Linux like Yocto. So here's what it looks like in our implementation. I mentioned in the previous slide the concept of optional modules. This is a good example of one. The first module that built out here is a module that implements an HTTP server. You'll see it in the demo in just a second, but we use that module to control, frankly, the demo, right? To control things, when things start, when things stop. You wouldn't necessarily need this in a real implementation, right? In a real implementation, you might want to go headless. The unit just turns on and does what it needs to do. Totally optional, but a great example of these modules that you can add in and pull out as needed. So when we start the demo, what this module first does is send effectively a start message on the bus that I was talking about in the previous slide, right? So that start message goes over the bus, goes over a broker, and into this discovery module. Now, the job of the discovery module is to go off and talk to the BACnet network and understand what it looks like. We make no assumptions what the network we're actually attached to looks like. We make no assumptions on how many sensors there are, what the names of the controllers are, how they're configured, et cetera. That is the job of the discovery module. And I highlight that for two reasons. One, it's a good example of how you take a problem communicating to BACnet and split it up into two pieces, right? You'll notice so far I've said nothing about actually grabbing information that relates to the current status of those sensors. I'm simply mapping out the network. So here we've broken that into two pieces, and we'll talk about the module that implements the polling function in just a second. But two, I highlight that because the job of this discovery module is to build an address book. And that address book we are putting on device in a very lightweight embeddable database called SQLite. And the reason I highlight that is it's a good example of showing how I'm not only constrained to communicating on this bus to other modules. I can come out and talk to the operating system. I can come out to disk. Great example, right? This database sits on disk. We create it. We write to it. We read from it multiple times. Good example of where I can just sort of blend techniques and use the gateway SDK, the gateway solution to talk to each other, as well as use the operating system to control other things that I might want to control. So what we wind up doing, we discover this network, we create this database, then we send another message back on the bus from the discovery module to the HTTP module that says, effectively, we're done. And I'll point that out in the demo. It might not be super clear when that message goes across, but you'll see in the demo because the impact of that is to close a WebSocket that we'll have open and tell us that we're complete. Okay, so finally, we have all this set up. I've mentioned already we have this polling module. The job of this module is to go off, inventory these devices, most importantly, get their current and present value and send that or package that really into this JSON payload that I mentioned earlier, right? So go off, get the information, put it into JSON, send that payload back on this bus, and then finally we take a module that comes directly from the Azure IoT Edge components, wraps it in AMQP, and sends it into the cloud. Okay, so lots of detail. Let's get into the code so you can see how we've implemented all this and how it really works. Let me highlight three key methods. And I'll show you ANSI C because my solution is built in ANSI C, but there are bindings available in the SDK for C#, Java, Node.js. So everything I talk about applies here, even though it's all in ANSI C. Just reflect that into the language of your choice as you develop your own solutions. But the concepts here apply across all of them. Right? First key method that I want to talk about is this parse configuration from JSON method. You'll see in a second that the function of this method is the gateway as it launches hands you the variables and the information that you've put into that JLOAD, the argument, the JSON file. It puts those arguments, makes those arguments available to you in this method. You can ignore them, you can overwrite them, you can store them. You'll see I do a little bit of all three actually in the code, just depending on what our needs are. So this is the very first method that launches. Once you've got all the arguments in, The very next method that takes over is the create method. Now this you can think of as the method you use to initialize a module, right? Some modules, as they start up, have work to do. And again, I'll show you a great example of that. Our HTTP module is exactly that, right? The work that module needs to do is set up handlers for all of the URIs and the URLs that we're passing to it, set up things like what is the document root, etc. So this is where you put that type of code. And then finally, the most important one to understand and for us to take a look at is the receive method. In the receive method, this is where you handle messages that come to you from the bus. You do things with them, you ignore them, or you take action, whatever it is. I'll show you all three of these. I'll run through a little bit of the code, and then we'll jump into the demo. There are a few other methods that are highlighted in some of the samples that you can get from the Azure Edge samples. I won't talk about those in depth because those are largely methods that you use to do things like free resources when the gateway shuts down, or any actions you want to take before the gateway shuts down. So we won't talk about those in depth. We'll really focus on these three in the next few slides in the demo. All right, so with that, let's break into Visual Studio. And I will go real quickly to this piece of code. So you'll notice here, BACnet.com, this is poorly named maybe, but this is the HTTP module. This is the code that implements the HTTP module. And I've started here in the parse configuration from JSON method, right? So let's look at the code. Error handling here at the beginning, nothing too interesting. Let's go down here to where we're actually looking at the JSON that's being handed to us, right? So you'll see here, and let's bring up the JSON on the side as well. Oops, excuse me. All right, let's look here. So you see here, let me make a little bit more room. You'll see here that I mentioned that this method, the gateway hands us the information from this file. I didn't have to write any of this code, right? So I am searching, though, for keys from this key value pairs that say something like BBMD address. And if you look down here in the arguments, I'm passing in BBMD address, right? You can see IP port, you can see TTL seconds, gateway name. This is exactly where we're pulling that information and we're storing it somewhere, right? So again, code's super simple, fairly self-explanatory. We're just getting that. I didn't have to write anything other than the logic of storing it and managing the data that comes in. Once this method is complete, it hands off to this method above that I'll highlight again as well, the create method, right? So here we are in the create method. And I mentioned this is the method where you do things like manage any sort of startup activities. This one, again, this is the module that implements the HTTP piece. So you'll see here, I'm setting things like setting the document root, right? What sort of listening ports are we doing? What's our timeout? Down here, also, we're using an open source package, so we didn't write any of the underlying HTTP logic either. But here we're setting up URI handlers, right? Again, this is as the gateway starts up. We're setting all this up so that when the gateway is ready to go and ready to launch, everything's ready for us. We can just open up a browser and launch into this. All right, so we've covered the first two methods that I mentioned in the previous slide, create and the JSON parsing method. The last method is the receive method. And for that, I'm going to go over to that polling module that I mentioned. You'll see here we're in the receive method. I want to give you some insight into what goes into that, right? So I mentioned the polling module really only takes action when everything else is done, right? It's only sort of waiting for the user to finish discovering, selecting which objects it wants to poll, and then saying effectively start polling. So here is where most of the startup logic, if you will, of the polling module exists, is in the receive function, because that's where all the information is coming from the gateway. You see here, there's a number of messages that come in. The one that's important here that I've mentioned, will go down, is once I receive a message that says really literally poll, right? So I'm looking for messages from the other modules. When a message comes in that says poll, I know everything is ready. We can get started. You see there's really literally only one method being called here, begin polling. Let's take a quick look at that method. It's actually a thread, so let me show you the thread that gets kicked off. This is the thread here This piece of code is the one that's actually sending out these native BACnet messages. Again, we won't get into it, but they're UDP messages with sort of BACnet-specific layers underneath the UDP payload that have things like, please tell me what your current value is. What is your current, effectively, your address, right? So you can get all this information from the network. Next set of code here is where we listen for that message to come back on a socket, a UDP socket. The important thing that I want to highlight here really is this last section of code that does converts it to JSON, right? So I mentioned part of the job of this module is to go off and talk to BACnet natively. The other part is to convert that into something more modern, more useful, a JSON payload. This is the piece of code that does that. And you see here, and you'll see the JSON more directly so it's easier to see. This is the piece of code that says, okay, the gateway name is this, and we extract the gateway name. The device ID name is that. The type of object I'm reading correlates to the type of sensor in BACnet, so you can have analog objects, digital objects, etc. Here is finally the return data, the actual value we're pulling out. And you'll see here we pull the data out. I put it into a JSON object string, and then I put that back out on the bus. And then that gets encapsulated in AMQP or MQTT. All right, so I hope you have an idea of what the pattern is, right? So send messages, receive them through the receive function, deal with modules as they come up through the create function, pass in information that are variable through this JSON file. Let's watch that in practice. Let's go ahead and watch that as part of the demo. So let me bring up a couple of things on screen here. So you see behind me, I just brought up, this is a virtual BACnet device. I'm not speaking to any of the real equipment in this building. One, it's a little bit hard to go with you, right? It's big equipment and it's usually in the roof. Two, it's actually it takes a long time to inventory an entire building. This is a single instance of a BACnet object. I can pull this and discover this in a matter of seconds, right? So we're going to use a virtual object today. For all intents and purposes, it's the same as talking to actual objects that are up in our ceiling. Let's go ahead and kick off the demo. All right, so we've started the gateway. Now let's go ahead and browse to that page that we've shown before. So, or browse to the page that was loaded by the HTTP module. So let's go here. You'll see here a very simple web page, right? Not much to it. What this web page, or what we'll do from this web page is once I hit that discover button, that sends a message out onto the bus that says start, effectively start. And that message is received by the polling module. So the job of the polling module is once it receives that start message, go off, inventory or discover this device out here, inventory that device to understand how many sensors it has, what type of sensors, create that database that I mentioned earlier. And then you should see, once we're complete, that database comes back, or that we pull the information out of that database and display it on this web page. So let's go ahead and start this process. You'll see it takes just a few seconds to go and inventory the device. It also talks to IoT Hub and is pulling some information out of IoT Hub. So you'll see here it says discovery complete. What happened there is it just took a little time, but what happened here is that we discovered the network, we inventoried this device, we got information from IoT Hub, put a message back out on the bus and said, okay, now discovery's complete. We closed a WebSocket that put this information on screen for you. So let's go ahead and look at what we've discovered. You'll see here that we've pulled all the information out of the database, right? Here is 12098. This is the device ID that we just discovered. This is a bunch of low-level BACnet information, but imagine what this really is basically what type of sensors are these? Are they analog inputs? Are they digital inputs? Are they analog outputs? These kind of things. And how many instances of each do we have? So let's enable one for polling. So what happens now is I will enable it for polling. I'll start the polling process. It'll go off and it'll poll this virtual object for its present value, right? What is the current status of the temperature? Where I'll display that temperature or that information is here on this tool that you may or may not be familiar with. It's called Device Explorer. Now, the point of this tool or the goal of this tool is to be able to pull information out of IoT Hub and to sort of display what's coming into IoT Hub in real time. So what you're going to see on screen in just a second is literally the JSON payload as it's created here on the device, reading the BACnet object, wrapped in AMQP, sent to the cloud. IoT Hub unwraps it, puts the data as sort of native JSON, and we're reading it back out here as it's sort of its native JSON implementation. You'll see it in just a second. So let's go ahead and start the process. You'll see here we are polling, and here on screen you see scrolling every few seconds. Is that information right? So look at the JSON real quick. Let me go ahead and hit stop the polling so we can stop the screen from scrolling. But you see, here's the JSON that's being created, right? You saw earlier, here's the gateway name, here's a timestamp, here's the device name, here is its present value, right? So again, super simple overview of what we're doing, but this is a key piece in enabling this smart building application, being able to take data from what was formerly an island, transform that into something we can put into the cloud. And now that it's in the cloud, the other side can start doing the cloud analysis, right? Start looking at the information coming in via ASA, even eventually start doing things like machine learning against that. That was my demo. I hope it gave you a good overview of how things work, how the overall pattern of implementing a gateway solution based on Azure IoT Edge works. Finally, I would encourage you to come and listen to the talk that's being given here at Build, excuse me, around the next generation and some of the vision around what's coming for IoT Edge. You see the breakout session there. I encourage you to play with the SDK that's available today on GitHub. The solution we had that you saw specific to smart building, specific to BACnet, will be made available on GitHub. It's not quite ready for public consumption yet, but as soon as it is, we'll put it up there. You'll see, of course, announcements from me, from my team. I encourage you to follow me on Twitter so that when we make these available, I'll send those announcements out and people can download the code and play with it. All right. Thanks a lot for listening. Bye.